everyone. Welcome to today's presentation from the DBA Fundamentals Virtual Group. As you see in the top left-hand corner of the screen, we are talking today about creating a YAML CICD pipeline for Azure Data Factory. Speaker today is Torsten Strauß, and today is July 8th, 2025. In the top right-hand corner of the screen, you'll see the three leaders of the DBA Fundamentals Group: Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. To the right of our names, you'll see our X handles. That's probably the easiest way to get hold of us. Just send us a message on there and rock and roll. Under that, you'll see various social media ways you can get hold of us. First off, being Meetup, where you can easily see all of our presentations that are coming up, get to the actual link to today's presentation, whenever that may be, on Meetup, so you can actually see our presentation. Hopefully most of you saw it on there. Below that is one of my favorite sites, our actual website, dbafund.com, where you can actually see all of our past presentations as well as our future presentations. So it's all fun and games at that point. Below that is our YouTube site, dbafundtube.com, where you can actually see all the past presentations. Be sure to like and subscribe to our YouTube site so you can see the presentations whenever they go live and be one of the first to watch it. Under that is our other social media handles for X, Slack, and on LinkedIn. Be sure to join us on there for all of our fun conversations we have there. Below are some of our upcoming conferences I want to point out. On August 11th through the 15th is TechCon 365. I point out the one that's in Atlanta because I'm based in Atlanta, so that's at least that one is always a big one for me because it is TechCon. And this year we're actually talking about Microsoft 365, Copilot, AI, and Power Platform. So there's going to be a lot of goodness there that everyone should at least be semi-aware of, what all it means, what it can do for you. And I'm sure most of everybody's management will love some of this information as well. So it never hurts to get as much information as you can, because that one's going to be a big conference this year. October 19th through the 23rd is the Community Summit in Orlando, Florida. Everybody needs to go down there just for that, just so you can experience Orlando, and they can also be inside a convention center, because who wouldn't want to be inside a convention center in Orlando where you can see anything and everything that Disney has to offer. Please remember to turn off your video and mute yourself. I know Torsten would love to have everybody paying attention to him instead of other things that could pop up on video. I've even turned my video off just so we can all focus on him. Please be sure to type any chats you want, questions you have into the chat, so we can throw them over to Torsten and he can answer all the goodness for all of us. We'll be asking those as we go along, so all will be good there. And with that, I have a small bio on Torsten up, but Torsten, you can have all kinds of goodness now because the screen is yours.
Okay, great. So let me take over the screen. I will introduce myself from just a PowerPoint slide, which I prepared. So hopefully the screen sharing is working.
It is.
Okay, great. So that's me, as mentioned. So my name is Torsten. I'm a consultant, trainer, and speaker. I'm specialized on Microsoft SQL Server, performance tuning, Azure CICD, or in general DevOps, Bicep, YAML, and all this kind of stuff. And that's mainly me. So in today's session, I want to cover how to create a YAML CICD pipeline in order to publish your changes from your feature branch to the main branch, including test and including, I would say, approval from your co-developer, so the peer review. So that means we will see how a pull request works and what you need to do from an Azure CI CD perspective yeah, in order to automate all these kind of, or the entire process. So it's a lot I need to cover. So that is the reason why I will close this one and will directly start with how to set up the environment. I have some notes. You cannot see the notes, but these are just notes, but I will share everything later. So I will, I don't know, upload this, the code or share the code later with the community, with a meetup group here. So, but anyway, I hope that I'm not missing anything, because it is not a very easy process, to be honest, and it took me a while. And yeah, I had a lot of iteration in order to make sure that it finally works and includes all the, let's say, the processes and all the features I like to have. And I mean, this is the YAML pipeline as I created the CICD process here, but it is up to you to refine it. I don't know, to maybe to add additional steps or jobs in between when you think it makes sense. So what I want to say, it is up to you to design your CICD process, because there's nothing wrong, there's nothing right. I mean, it is wrong when it is not working, but it is, as far as it is working and you fulfill the requirements, you are done. Maybe your pipeline doesn't look that complicated, right? But maybe you have different business requirements. It means you need to introduce more steps, more jobs, or whatever, to make it more reliable or secure or whatever. So again, this is my idea, and it's completely up to you to change it. So let me go into the code and what I did. So I just want to make sure that the Teams is not hiding my screen. So now it should work. So what I have is very simple. I have one Azure Data Factory instance here, which I called ADF Data Core Dev minus West Europe minus instance, which is over 1. So, and we have another one, which is called test, right? And you can imagine that, I don't know, maybe you have pre-prod, you have prod, or even a completely different instance. And now you want to synchronize the work you're currently doing as a developer in the development instance, right? You want to synchronize the work with the main branch and finally push all the changes to the test and hopefully finally to the production environment. And that is for sure something you want to have in your control. That means you have to, and we will see how it works, you have to define environments, and at least you have to set up approvals and stages and everything like this. So I guess you get the idea, rough understanding of how we want to, or what we want to accomplish. So we want to have an automated process to push the changes from development through test and finally to production. So that is the idea. And I mean, this is typical for a CI/CD process. It's always the same. So, and now let's go into the code. So let's start with the development environment. I just want to make sure that I'm not mixing it up. So maybe it's better to line it like this. Yes. So let's go into the code. So again, we are now in the development Azure Data Factory instance, and this is for sure where your journey starts. I mean, you can develop without having a CI/CD process when you are the only developer, and finally you don't care about, I don't know, merge conflicts or whatever. So, but as far as you, or when you're working in a small or even in a big team, I would say it is impossible to develop without having a CI/CD process, which is sure for Azure Data Factory. It's also, I don't know, sure for SQL database, C# projects, or whatever. So you do yourself a favor. Do not start without having a proper CI/CD process, because when you start without, I'm pretty sure you will end up in a mess. You know? So, and then it takes much more time to resolve all the conflicts and finally have a running system. So it means you have to invest time in your CI/CD process before you even start to develop. That is, I would say, it is how can I say? It is a change in the way we are now developing. So without having a CI/CD process, again, I don't want to recommend to start even writing one line of code. So let's go into the code. What we have is we have the Azure the factory instance here. Again, this is the development one. And the idea now is to make sure that everything we are doing here, every change we are doing, will go to our or into our Azure DevOps repository. So what I want to share is, first of all, this is a picture which I have. And you can imagine what happens, because I already mentioned that you will end up in a mess. So I will explain exactly why you will end up in a mess when you're not working alone. So you can see on the left-hand side, you have a developer 1, and on the right-hand side, you have developer 2. And for sure, maybe we have much more. So, and what happens when you do your changes in the UI? So that means I will go again to this environment, I don't know, create a new pipeline, a new, I don't know, data set or whatever, any kind of change. And when I now press save, so what will happen is all the work you're currently, all the changes you did is nothing else than ARM. So that means it's Azure Resource Manager. So it's a JSON format, which is, usually you work with Bicep one, but when you use Bicep, it is locally transpiled into JSON, which is nothing else than ARM. So ARM is let's say, the language which you use in order to tell the Azure Resource Manager which changes you want to apply, which resources you want to create, or maybe which resources you want to delete. So it's like a blueprint. It is always the single source of truth, and what is included in the ARM template will be published. And when a resource isn't a part of your ARM template anymore, it will be dropped, depending on your settings for sure. And when you do a change, when the ARM template is different to the Azure resource, then all the changes will be applied. So now you can imagine what happens. I will save my changes. So that means I will work in a feature branch, and a colleague of mine will do changes, and all the changes will be saved in his, let's say, his or her feature branch. So that's perfectly fine, because we are working independently. So we have two feature branches which are currently working independently. The feature branch 1 doesn't even know that there is another feature branch, so no problem here. But when I now go back and say I want to publish, and this is not available anymore because I disabled the functionality of publishing to main branch because of the reason I want to explain now. When I will publish without having a proper CI/CD pipeline in place, the first developer will bring his changes into the live metadata repository. So that means this is a version which becomes alive. So you have a live view in Data Factory. So, and that means currently I'm the winner. I'm the owner, or maybe the author of the live version everyone will see within the Azure Data Factory. The problem is now when developer 2 will do some changes based on on the first version, on his version, and he will publish the code from his feature branch into, let's say, the live metadata repository. He will completely overwrite. There's nothing like a merge conflict or whatever. He will completely overwrite all the changes developer 1 did. So it means you have something like a last winner scenario. So, and this is nothing you want to have. So in order to avoid this, we have to make sure that all the changes happen in the dedicated feature branch will be automated and finally merged into the main branch. That means when developer 1 will do who did some changes, developer did some changes, developer 2 did some changes. And finally, maybe they worked on the same object and they have a conflict because developer 1 decided to do a change which is completely different to the change developer 2 did. Then the CICD process should, I would say, stop the entire merge process and visualize the merge conflict, right? So that is the idea, because otherwise, again, the last winner, takes it all. So that is a problem. So how can we achieve this? Let me go to the Azure portal, and what I will do is I will just create another data factory instance. At least I will start here within. I have a bicep template for sure, which does everything for me, but I don't want to dive into bicep now. That is the reason why I use UI. So we can define, I don't know, usually you have a much more meaningful name. So you decide maybe Germany or whatever else. Okay, I don't have something like this. It's already taken. Okay, cool. So when I now press next, you will see that you can configure Git. So either you can configure Git when you create, or as part of creating your Azure factory instance, or you do it later. That means usually you can skip this step, but then you have to ensure that later, before you even create your very first object, you go to the management blade here on the left-hand side. Here. You can see it. Here we have, underneath source control, we have the possibility to edit the Git configuration. So again, either you do it here or you do it up front. So usually I preferred to do it here within the UI, but it is up to you. So there is everything which is available here is also available during the, let's say, deployment. Yeah. So what you have to understand, first of all, you need to have a repository where you save all your changes, right? Which is nothing else than ARM. It is an ARM file, as we will see. So that means you have to enter the repository type, which can be either Azure DevOps Git or Git. Yeah. So I decided to go with Azure DevOps Git. Then you have to name the account. Yeah. DevOps account is a little bit misleading. So this is the organization. Then we have the project name. You can see can we see it here? Not here, but you can see it when I open Azure DevOps later. Or I can do it now. Let me go to here. So you can see this is my organization. This is my project. And this is exactly what is required, right? So organization, project name. And then you have a repository. So this is something you should set up up front. Then we have a collaboration branch, which is called main, and a publish branch. The publish branch is ADF publish by default, but there is some kind of a background noise. I don't know where it comes from. I have no idea. No, it's better. Oh, no, it's not better. 1 second. Now it's gone. Okay, cool. We have a publish branch here, which is by default ADF publish, but this is nothing we want to use, right? Instead, okay, how can I get rid of all the windows now? This is super crazy. I have no idea. Oh, no, it's gone. Cool. So we have a publish branch, which is the ADF publish branch. This is a default publish branch, but this is something we don't want to use, because what we do is usually you go here and say disable publish. Something is wrong with Teams here. I cannot click anymore. Okay, I have no idea. Teams is popping up, and but anyway, just imagine that you would disable publish from ADF Studio in order to make sure that you have to follow the CICD process, and I will show how it works. So because we want to avoid that someone will use the live metadata repository, and again, we will end up in a mess because last winner will overwrite the former changes from the former developer. So that is something which is usually disabled. It is enabled here, but I don't care for a moment. But when you set it up, you should do it properly. So that means every single change you are now doing within the Azure Factory UI is automatically pushed as a commit, right, to your Azure DevOps repository, which you set up in this way, which is already, I would say, definitely best practice, because you are not losing anything. Because otherwise, when you don't have any Git implementation, as far as you close your browser and the cache is gone, all the changes you made are gone. That is the reason why you have to have some kind of a version control, in our case, Azure DevOps repository, in order to make sure that you're not losing any kind of change, because otherwise it's just local development within your browser. So let's go further. We have our Azure DevOps repository as mentioned, and now you have to define a few things. When we go to our, I don't know what happens. I cannot click anymore. Now something is wrong here. 1 second. Still not working. What is wrong here? 1 second. This is crazy. I cannot resize a window anymore. This is nice. This is what I like. I have no idea. I cannot click anything anymore, this is crazy. 1 second. Nope, not working anymore. Let me close this one. Let me do this. Can I do it now? No, it's not working. This is great. I mean, nothing you want to have in a session like this. 1 second, maybe it's a problem of my mouse. No, it isn't. Let me try to reshare. So nothing is working anymore, which is great. 1 second, I will reshare. Maybe it works now. Reshare. I hope it is working now. This is crazy. It's better than before, not perfect. Anyway, let's give it a try. Sorry for this. I don't know what's going on. I think it has something to do with Teams. Anyway, so now I'm completely lost. Yes, I was looking for my notes. I'm losing my notes, but okay, that's okay. So what we have here is, so we need to set up several things in Azure DevOps in order to make sure that our pipeline finally works. So first of all, what we have to do is, and the order really doesn't matter, but we have to do it upfront before we create the YAML code. So what we can do here is, what is wrong here? This is super annoying. Sorry for this, but I cannot switch the window. What is wrong? I have no idea why it is happening. Let me do this. I will unplug my monitor. Maybe that works. No, it's not working. This works. This doesn't work. Okay, let me go from here. Hopefully it works. Let's go to library. Yeah, this works. Okay, so what you have to, before I want to go to environment again, the order does better. So therefore, let's start with library and hope that at least this will work. So what we have here is we have a library which I called ADF Data Core, which is nothing else than a library is a group of variables which are shared across one or more pipeline. So we can see that in this case, we have a lot of variables here which are shared across all environments. And when I'm talking about environments, I'm talking about the Azure Data Factory instances. That means I can define variables which can be used by every single instance, which is development, test, and production. You can see, for example, that I define a package.json folder or pool name or whatever root folder, which seems to be common, right? So then we have another library, this one. And this here, for example, the development one is dependent on the development instance. That means this is a place where you have to save variables which belongs to the instance. So we can see, for example, the data factory name. So the data factory name is ADF, Data Core Dev, West Europe instance 001. So when I don't want to open the test library, but you can imagine that when I open the test library, you can see that there's a data factory name, which is called ADF Data Core Test minus West Europe minus 001. That means this variable will define the environment or the Azure Data Factory instance, right? So therefore we have one global library and we have n times a library for every single instance we want to deploy. So that is the idea, which makes it very simple and very reusable, I would say. When you think about, you have another environment which we will call pre-prod or whatever. The only thing you need to do is we have to do some changes in our YAML code, which I will show later. But you can imagine that first of all, you just have to create another library, which is called pre-prod, and you have to define the variables to describe the pre-prod environment, mainly the instance name. So the next thing is the environment. So an environment is something which you can assign to the deployment within your CICD process. So a CICD process is nothing else than continuous integration, continuous deployment or delivery. So CI means you're building your code. So once your code is built, so it means parsing and syntax check, everything is done. So you finally, in our case, get a valid ARM template. You can take this ARM template and push it to development, test, and production, which is the deployment. So within the deployment, again, you can assign environments. So it means, let me open one of the environments here, which is this one. I don't know what is wrong with my laptop here. Let's go with this one because for whatever reason. What is going on here? Sorry for this, but this is super annoying. I have no clue. 1 second, let me try to figure out what the reason is, because otherwise it's super annoying when something like this isn't working. Let me close this one. Maybe that is a reason. No, it's still not the reason. Let me stop sharing another time. Sorry for this, but no, it's. Let me try to do this. It seems the Teams completely crashed my session. Let me go to best performance. Maybe that, that works. Okay, good. Okay, again, I'm a little bit lost, but I want to explain what an environment is. So you can see for every single instance, which is dev, test, prod, I have an environment. Let's open the test environment. And within the test environment, you can define gates, you can define a lot of things, but the minimal requirement is that you create a so-called approval or check. That means the idea now is that someone has to approve the stage. I will show you how it works. The stage within your CICD process, which is in our case the test environment or the test target, and for sure it's the same for production, so that the ARM template will be finally published to the test environment. So I'm the only, let's say, developer in my own organization. That is the reason why I will approve my own changes, not the pull request, but the stage itself. That doesn't make sense in some kind of a bigger environment. But you can imagine what will happen when you don't have an approval. That means once you run your CICD process by a pull request or whatever, all the changes will be automatically pushed to development, test, and finally production without any intervention anymore. And that is something you want to avoid. Someone needs to approve the release, because usually you have a release after every single sprint, which is maybe, I don't know, 14 days or whatever. And here, if you don't have approval, the entire CI/CD process will publish the ARM changes to test and production already. So that is not a proper release cycle. So now we have our library in place, we have our environment in place, and what you have to do now is you have to set up the files. So it looks like this. I have a top folder here, which is called ADF. And within ADF, you have a folder, at least I have a folder, which I called build and deploy. Here you have to define a few files. Let me blow it up a bit. So this is something which you can easily copy and paste. There have to be a package.json file, and this is content which is required. Don't ask me why, it is required. So we have another file which is required, which is the so-called publish config.json. And again, it is just copy and paste. You call the publish branch ADF publish, which is not even used. So therefore, I don't understand why we need the publish config.json file, but it is like it is. And that's it. So that means you have your Azure your Azure DevOps repository in place. You have the two files in place, which I mentioned already, the package.json, the publish config.json. And now the very first time, or before you even create your very first object, the data factory itself is already an object, right? It is a resource. That means for the resource, there is an ARM template. So that means we have to go to the ARM template here within manage. And what we have to do, which is a little bit, I don't understand the reason why it is named like this, but we can say, or why it works like this, we can say now edit parameter configuration. So when I do this, at that point in time, the ARM template is already published to your main branch. That means this is the initial commit, and therefore this is a definition of your, let's say, empty ADF instance. So that means you can now start to develop, and you can now use your feature branch, and the feature branch, the ARM template, which you're going to create by doing all the changes, definitely is not in sync anymore with the ARM template, which is saved in the main template, in the main folder, not the folder, the main branch. That means when you now create a pull request, your ARM template will automatically compare with the version of the initial setup of the Azure Data Factory, and the CI/CD process will automatically detect the changes and just push the changes in an incremental way to the next environment, which is dev test prod. So this is how it works. So let's go into the code. And now it seems to work, which is great. I don't have any problems anymore to open a window. Sorry for the technical issues, but you can see it is really caused by Teams. So what you can do is the following. We can create pipelines, and I will create a very easy pipeline with just a wait activity. This is the easiest pipeline you can do. You can set up more sophisticated pipelines. I already have a few of them here, but it doesn't matter how complicated your pipeline is. When you follow this approach, everything will work. So the idea is the following. We will go to manage. We will go to linked services. And the first thing you need to do is, at least this is how I'm doing it, you can create a key vault within your resource group where your Azure Data Factory currently lives. So why? The reason is the following. Everything, or when you allow usually you have a managed identity for your Azure Data Factory, and when the managed identity is a key vault, has a key vault reader role, the managed identity of Azure Data Factory, which means Azure Data Factory can read all the secrets from your Azure Key Vault. Why is this important? First of all, I don't need to save any, let's say, secrets to create a linked server later on. I can fully rely on a key vault, which is protected by soft deleting and backup and whatever you want. That is definitely a big advantage. And you have just one central place for all your secrets, which belongs to Azure Data Factory and maybe even other resources, because it's very usual that you share the same secrets with other environments like, I don't know, SQL database or Fabric or whatever. So that is the first reason why I usually prefer to have a key vault. Second one is, you can see the base URL. So within the, let me go to the key vault. In our test environment, we have the same key vault, which is called dev, in our development environment, but I'm pretty sure you get the idea. So we have one secret, which I called SQLDB data core connection string. So, and again, we can add more and more secrets. So that means when I now open Notepad, which is almost impossible because Teams is hiding, no, it works. So when you do something like this, you can define all the connection strings, all the secrets within your key vault. Why is this important? You can see here in the connection string, for example, I have a SQL database, which I call test. You can see it here, test. In my development instance, I have the same key vault, and I also want to connect to a database, but not to test. I want to connect to development. And in production, yeah, for sure, I want to connect to production. So how can I achieve that whenever I publish my ARM template from development to test to production, the test and production will point to the right SQL database? That is easy. When everything relies on the key vault, you just have to go to the ARM template, and I will show it later to you, and overwrite the URL of the key vault. Let me go back to, sorry, a little bit long here. So the only thing I need to do is to make sure that the base URL is dev in development, test in prod in production. Nothing else is, you don't need to change anything else than this. Because when you now rely on the key vault secrets, the only place you need to change is the base URL. So that is, I would say, a very easy way to do it. And this is a great achievement, was the way Microsoft set up Factory, and the possibility to use secrets from one central place, which is our key vault, makes the CICD process super easy. So when you have this in place, you can now create whatever you want to create. Let's go to SQL database, for example. And here we can see in the ARM definition, let me go to the ARM definitions. It's definitely easier to read than from the UI, from my perspective. So we can see we have the reference of the parameter, which I call connection secret, which is nothing else than the name of the secret within the key vault. That means when I now use the name of the secret within the key vault, the entire connection string is injected into the linked service. And again, depending on development, test, or production key vault, you get the right connection. So keeping this in mind, you can now create your data sets, make it absolutely flexible. You don't need to change or hard code anything anymore, which is super easy to create. I mean, it takes some time to set it up in a proper way and to understand the concept. But when you have everything like this in place, we can now go into the YAML code. The YAML code looks like this. I think this is something I can close. Yes, so this is the repository. And my first recommendation is go to the branch policy for main and make sure that, I just want to make sure I'm in the right repository, perfect, that you ask for a pull request. That means you have to go to the main policies here and enable require minimum number of reviewers. Again, I'm the only person in my organization. There's no one who can approve my pull request. It doesn't make sense for demonstration. It's definitely fine. I even need to enable a low requester to approve their own change, because otherwise I'm waiting for another person which doesn't exist to approve my change. This is definitely not good practice. So for sure, we can enable check for linked work items in order to associate your work with a task in your task board. This is the only way or the only justification to develop without having any kind of work items defined in your board. You shouldn't even start to work. For now, that's perfectly fine because I don't have a board in place. You can say check comment resolution, which means someone is doing the peer review and left a comment. Yeah, so I don't know, any kind of suggestion or even an error which you need to resolve. That is, you need to answer comments. You need to resolve them. So again, for me, it doesn't make sense. I'm the only person in my environment, in my organization. And now you have the YAML code in place, and I will show you the YAML code for sure, but the pipeline is already in place. That means I will enable the build validation. So what is build validation? Whenever I publish the other way around, whenever I push my changes to my feature branch and finally call a pull request, someone has to approve my pull request. Okay, now someone will go to my code, which is a little bit hard to read because ARM is definitely something you don't want to read, but you want to rely at least on the build process. You want to make sure that the ARM template is error-free. There's no, I don't know, often reference or whatever. So that means you want to ensure that at least the build process is it is running before you can even approve the pull request. That means you can only approve when the build was successful. And now you can go into the code in order to understand, I don't know, business requirements, which is definitely not dependent on the success of the build, because the business process is nothing which you can, I mean, the build is successful or not, even if the business logic is wrong. So that is something you should do as a developer, but you shouldn't go into the ARM template in order to understand if this will be finally a successful build. So this is what you can do here. So that means when you now commit just the build, so the CI part of CICD, the pipeline will run, but it will automatically skip the deployment phase because you just want to understand whether the build was successful or not. If it fails, you cannot approve. If it is successful, you can approve. So this is how it works. And so in this way, no one can push changes into your main branch anymore without calling the CICD process, which will definitely protect your code, because otherwise, again, you are in trouble because the developer which will push the last change into main will completely override the existing code from the former pull request. Right? In this way, the main branch is protected. So now let's go into the YAML code. So the YAML code looks like this. You're back. This is the YAML code. So what you can see here is a great way, not because I created the pipeline, but I really like the idea and the possibilities you have within YAML. So what you can do is you can, for sure, we are not going into detail, so I'm not explaining every single code line. Just want to give you a rough understanding what the pipeline is doing and why it is so flexible and powerful. So what we have, and that is something which you can do within every single pipeline, not just for Azure Data Factory, also for SQL database, for example, you define a variable, not a variable, sorry, a parameter, which is called targets, which is a type of object. So you can, in YAML, you don't have an array, right? So, but I consider this to be an array, so where you have property value pairs. Value pairs, which means you have a name, which is development. You have a stage, which is called development. Then you have your Azure subscription, which is your service connection, right? And this is associated to this environment, which is in our case development. Then we have another stage or another target, which is test. Here I need to define the service connection because usually you have one service connection per environment. And you can even say you want to have a dedicated or different deployment pool name, maybe a self-hosted integration runtime or whatever. So that is something you can do here. Why not doing this in the library? These variables cannot be defined in your library because, for example, you need to know the service connection and you, or not you, but YAML or CICD, DevOps needs to know the service connection and the pool before even starting the pipeline. But when you start your pipeline, these kind of variables, which currently resides in the library, are not visible for the pipeline. So it's something like a chicken egg problem, right? That is the reason why we define these, let's say, these variables here in the pipeline itself. All the other variables are part of the library. So there is no other way to do it. But to be honest, this is not a very big, it's not a, let's say, a showstopper, because you can see it's super easy. I mean, it's just the Azure subscription and the pool name. So, so what we will do here is, first of all, we define a lot of global variables to have, semantic versioning in place, which is either based on an incremental, where you can say you have a minor and major version, which is part of our library. Let's say you want to have a new release and you want to call the release 2. At which should start with 2 as a major version. I don't know, 10 as a minor version. And then you have an increment, which is increasing every time you run a new build, right? That is semantic versioning. Or you can have a semantic versioning based on the date, and you have an increment in the beginning, in the end, right? So it's up to you. That is the reason why I don't want to go into the library another time. But in the library, you have a variable which is called minor version, major version, and you can say, do you want to rely on major version, or do you want to rely on a date plus an increment? Okay, so next is we are building the ARM template. That means all your changes, again, this is nothing else than a definition of your ARM template. And we want to ensure that the ARM template is error-free. All the references are there, no often the references are there. That is the reason why you should usually have a build even for an ARM template. So here we do, or we define the package versioning, for semantic versioning, not very interesting. The next thing is we build the artifact. That means the ARM is now becomes an artifact. I will cover what an artifact is after explaining how the YAML code or pipeline works. And we need to install Node.js for the export of the ARM template. And here we are using some caching in order to make sure that we don't need to install Node.js on a self-hosted integration runtime or even on the Azure pipeline. Not in the integration runtime, on the, pool. And here we can see we are not installing Node.js every time we run the pipeline when it is already there. And because it takes some time, I want to avoid time, right? Why should I install a tool which is already available? So that means we rely on caching. So, and after building the ARM template, we will copy the ARM template and finally publish the artifact, which is nothing else than the ARM template, to be consumed from the next stage, which is test in production. And also, finally, we will publish the artifact into the artifact feed, right? For debugging, I usually have something like this in place. This is just for debugging. And finally, when the build is done, we will call another YAML template. This is not a pipeline anymore. It is just a template. I have a bunch of templates available which can be reused. So the idea is the following. You can define a pipeline. You can, I don't know, in the pipeline you can see that we define minor, major versioning, semantic versioning. We define some package variables in order to identify the run. This is something which I call custom, right? So this is up to you how to define it. The deployment is something which can be reused by every single pipeline, because in the end, you definitely have a deployment stage, right? So therefore, I call a YAML template within a global repository, which will be checked out when the CICD process or the pipeline starts. And the good thing is, no one really needs to worry about how to deploy the ARM template to the next stage. You just have to ensure that you pass the right variables to the template, which is, for example, the factory name or the key vault base URL. And in the library, I think I need to go to the library another time because otherwise I'm pretty sure you're lost. Let's go to the library. Here within the library, this is bicep, sorry, ADF here. Here you can see that I'm injecting or I'm changing, not me, it's Azure DevOps, changing the property of the base URL of the specific linked services, which is a key vault within the ARM template. That means it will be the variable, the value of the variable will be, or the existing URL within the ARM template, maybe that's the better way around, will be replaced by the specific base URL, which we will have in our library. So, and that makes it so flexible. The only thing we need to do is we need to override the base URL when we deploy to dev, test, and prod. And this is a value which is finally used. It's part of the library. It cannot be part of the key vault because otherwise we have a check-in problem as well. So let me try to run it so that you have a better understanding of it, how it finally looks like. So this is my development environment. And this is my test environment. And first thing is we have to create a new feature branch. Let me create a new one. Let's call it users. Torsten. Feature. This is just my naming convention. O2. Yeah. Usually, associate your work with an existing task within your Azure DevOps. Yeah, so this is you remember that we can enable a linked work item. Yeah, so that no one can create a new branch without having a dedicated task, which describes the work you're going to do. And for sure, we can say based on main branch, which is the latest release. And now I can work completely independent. That means I'm working exclusively in my feature branch, and another developer is hopefully working in its own dedicated feature branch. So let's do it. Very simple one. Let's go to projects, create a new pipeline, call it pipeline, I don't know, demo, and go with wait task or wait activity. I think I don't need to define anything. No, it's working. Let's say save. At that point in time, I'm saving my work to my my feature branch. And what happens next is I can say, create a pull request. Now you will be automatically redirected to Azure DevOps. So usually you have a much better description than this, but it's fine for the moment. I can include additional reviewers. So I don't know, specific teammate needs to review because of, I don't know, specific business requirements. I have no idea. So here we can link work item if you have an Azure DevOps board in place, right? I don't have any. So now I can say create. So once this happened, hopefully it works. Yes, perfect. The CI process, you remember the build validation, which we enabled within the branch, is now running. So that means when we go here, it should take not longer than a minute, I guess. It's super fast because we are just building the ARM template and making sure that we have finally a semantic versioning in place. That's all. A minute. So yes, we need to wait. Let's wait for a few seconds because otherwise I cannot continue because I'm dependent on the successful build. What I can do in the meanwhile is I will open the artifact feed because I have already a lot of artifacts available. You remember that I mentioned that it's a good idea to bring the ARM template to an artifact feed. So what is an artifact feed? An artifact feed is something where you can publish your, as a result of the build, which is called an artifact. In our case, it is an ARM template for reusability, for auditing, for monitoring, and for sure you have the possibility to roll back to a specific version because the ARM template, which will be finally published when everything went well as part of the YAML definition, is nothing else than a snapshot of your pipeline. At that point in time, you push your changes to dev, test, or prod. That means there are a lot of good reasons to use an artifact feed and to save the ARM template as an artifact within your artifact feed. So now the pipeline is done, but let me open the link. I just want to show how it works. So I have a dedicated one, which is called ADF Data Core Dev. I have one for prod, one for test. Let's go to dev. So you can see the semantic versioning in place, which is started with 2, which is a minor version. We have the major version, we have the minor version, and we have an increment, right? So that is how it works. I don't want to do it, no, because otherwise I have to open a Visual Studio Code, but you can easily copy the code when you have, when you have a personal access token. So you are allowed to download the artifact feed. The personal access token is something you can use or you have to use in order to connect to Azure DevOps, and dependent on your permission, you hopefully can download the artifact from the artifact feed. And what you will see in the end is the ARM template and all the parameters to make sure that you can restore this version. So I don't want to do it. You can believe me that this is nothing else than a zip file within, I think it is a zip file within the artifact feed, but finally it's extracted and you can see all the files which belongs to your last release. Let's go back to the pull request. Where's my pull request? A little bit lost. Let's go to pull request. Correct. This is the one which is still waiting for an approval. Let me approve. And now this is something which really took a at least for me, it took a while to understand why we have another build phase here. So what will happen now is so Azure DevOps will merge my code changes to the existing code, which is ARM, within the main branch, brings everything together and creates a new build. That is the reason why we have 2 builds, one for your, let's say, for your commit before the approval of the pull request to make sure that my YAML template or my changes within my individual branch is working. And now we are merging my code changes into the main branch. The result is for sure a new YAML template, because, I don't know, another person, another developer also merged his code into main. And now it will, Azure DevOps bring all the changes together so that we have a new YAML template. A new build will happen to make sure that this version, which is very likely not the same version as the one which you have in your feature branch, is also something which can be built. And if this is done, finally, we can say autocomplete. And when we now go to approve, at least one besides, oh shit, I think I did it wrong. Security, sorry, policy. Let's go to allow. Okay, I don't know whether it works for an existing pull request. Otherwise, okay, let me do the following. I will go to the pipeline, to the run which I did before the session to make sure that everything is working. You can believe me, it is exactly the same, but you remember that I forgot to change or to set the settings so that I can approve my own run. So this is how it works. So we have our build, we have our deployment, right? And in parallel, this is something which you can define with it depends on property within YAML. I don't see a reason to run it in a sequential way because development is something for me which is independent from test. Here I can now run some unit test, I don't know, whatever business logic. And finally, you remember that there was a YAML pipeline which skipped the production environment. But in the end, you have another stage which is called production. I don't even have a certain environment in place because the idea is exactly the same. And within the, let's open this one. So we can see here that apart from the build, which is the same for development, test, and production, we now have our deployment phase. So, and a few sentences on this, then I'm done. We have to ensure that if there's any trigger running in the Azure Data Factory instance, in this case test, the trigger will be stopped because otherwise the pipeline will be executed at the same point in time we are trying to, or not, we're not even trying, we are overwriting the YAML template. That means the pipeline is maybe gone or some changes on the pipeline happened due to the YAML template we now publish to development, test, and production. So that means we have to stop the triggers, to make sure that no pipeline is running at that point in time we are deploying. So, and now we deploy here, and we start the triggers afterwards, to make sure that schedules are in place, pipelines will be executed, and so forth. And finally, as mentioned, when everything works, and only then we will publish the YAML template to our artifact feed, again, for monitoring, for debugging, for restoring, and also to make sure that we have some kind of versioning in place, which definitely helps in order to understand what happened when something happened. So this is how it can work. Again, this is just an idea. This is at least the way I'm doing it. That doesn't mean you are forced to do it in exactly the same way as far as you follow the, let's say, the CICD or Azure DevOps principles. That means you have to have a CICD process. And please do yourself a favor, create a YAML pipeline, at least a minimum configuration, before you create you start, I don't know, creating your first pipeline or whatever. Because otherwise, again, I'm 100% sure you will end up in a mess. So my strong recommendation is create a YAML pipeline like this. Maybe you several iterations, and finally you have a very well automated process which is fully controlled and which is almost bulletproof, I would say, for all the reasons which I mentioned. Yeah, that's it. Do you have any questions? No question.
I don't see any in the chat, but I do want to remind everybody while they're thinking of their questions that we do have some upcoming presentations coming along. The next one is actually on July 22nd. The DBA Survival Guide 360 Degrees of Survival SQL Server Backup and Restore with Teo. And then on August 19th is the DBA's Essential Toolkit with Ethan Blumen. Everybody's heard him, and I'm sure loved everything he had to say, so he's coming back for more. Just want to remind everybody that, and we will actually be putting out the recording, like I said earlier, that we'll actually be putting out here in the next few days, so that everybody can watch and see everything you ever wanted to know about CICD and Azure Data Factory. Hopefully be out there later this week.
Cool. Yeah, then thank you again, Kevin, for having me. And hopefully we will see each other, I don't know, in person sometimes, or maybe next year in this meetup group.
That's what we're hoping.
Okay, cool. Thank you very much. See you soon.
All right. Thanks, y'all. Have a great day.
Bye.
See you again.